We saw this in the previous class, guys. For any right angle triangle, okay, if we have the perpendicular sides A, B, okay, and the hypotenuse or the largest side opposite to 90 degrees as C, then C square is equal to A square plus B square. This is the Pythagoras theorem. Okay, that means for the hypotenuse square, so the square of the hypotenuse is sum of the squares of the other two sides. Okay. Second thing which I wanted to point out, guys, which I did not discuss previously, was see, for any triangle, okay, for any triangle, let's say having vertices P, Q, R. Okay, suppose for example, the side opposite to the vertex P will be denoted with small p, letter P. Okay, the side opposite to the angle Q or the vertex Q will be small q, and the side opposite to the vertex R will be small r. Okay, so it's a convention. Okay, whenever it's not given generally, they'll directly say in a triangle PQR. Okay, P is equal to 5 centimeters, Q is equal to 4, and R is 3, blah blah blah. Okay, whenever they give you this convention, always remember that they're talking about the sides opposite to the respective vertices. Okay, it's as simple as that. Okay, there are two buildings, 1 and 2, situated across two sides of a road, 132 inches wide as shown in the figure. Okay, this is the figure which we need to study. Okay, the bottom end of a ladder is located at the point C and touches the building 1 at a height of 45 inches. Okay, now keeping the lower end fixed at point C and turning the ladder around, the other end of the ladder now rests on the building 2 at a height of 21 inches. Okay, find the distance of the point C from the building. Okay, this is the question. We have to find the distance of this point P from this building. Okay, basically we have to find the distance of this point C from this first building. Okay, distance find karna hai. Okay, you can try it out. You can just pause the video for time being and try it out. If not, you can again resume the video. We are going to discuss it anyway. All right, guys. So I'll just again explain what exactly happens in this question from start. There are two buildings, as you can see, building 1 and building 2. Okay, at the point C, okay, I have pivoted, or I have basically stuck a ladder here at this point, okay, which is in contact with the road here. Okay, this ladder is resting at a height of 45 inches on the building 1. Now what happens is, okay, you can just keep the point C fixed here. Okay, keeping the point C fixed here, I am going to turn the ladder like this. Okay, and now the ladder will meet the other building at a height of 21 inches as per the question. Okay, so as you can see, I can clearly observe that the ladder ka length will remain the same, and the ladder ka length is nothing but the hypotenuse of these two right angle triangles, right? Isn't it? So I can just call these two hypotenuses as L, or the lengths of the ladder. Now we want to find this length A, guys. You can see it flashing on the screen right now, the length A right now, the distance of C from the first building, if I can, right? So I'm supposed to find this length A, as you can see. Now guys, from the question, the length of the road is 132 inches. Usme se A is the distance of C from the first building, right? So what is the remaining length? 132 minus A. Okay guys, so if you can observe, I have one right triangle having sides A, 45 and L. Okay, and the other having sides 132 minus A, 21 and L, right? So I will need to write two separate, I will be needed to write two separate Pythagoras theorems. So I'll write that for the first triangle, it is 45 square plus A square equals to L square. And for the second one, it's 21 square plus 132 minus A the whole square equals to L square. Okay, L square is same on the right hand sides, equating the right hand sides. You have 45 plus A square equals to 21 square plus 132 minus A the whole square. Right now, guys, if you open the right hand side using A minus B the whole square, okay, generally people do that and they say ki equation bahut lengthy hai, wo solving bahut difficult hai. Okay, instead of doing that, what you can do is you can just take the constants on the one side and the variables on the other side. Like you can take 21 square on the left hand side and you can take A square on the right hand side. So what will we have, guys? On the left hand side, you have A square minus B square. Can you see this, guys? 45 square minus 21 square. 45 is A, 21 is B. A square minus B square. Same way, 132 minus A, the whole square minus A square is again A square minus B square. So both the sides now you can just expand, guys, as A plus B, the whole A minus B into A plus B, right? That is A square minus B square, right? So 45 plus 21 into 45 minus 21. 132 minus A plus A and 132 minus A minus A, right? Now, guys, if you solve this, 45 plus 21 is 66, minus 21 is 24. This will give you A cancel 132 and minus A gives you minus 2A, right? Now, you can just cancel out 66 ones are and 2s are 2 ones are 2 12s are. You will have 12 equals to 132 minus 2A. Taking 2A on this side and 12 on right hand side, you will have 2A equals to 120. or you will have A equals to 60. That is the required answer. The distance of C from the first building is 60 inches. As simple as that. In the given figure, there are two squares and the side of the smaller square is 3 units. Find the area of the bigger square. Okay, you can just again pause the video and try it out, and you can just resume it to look at the solution. All right, so what we'll do is we'll start by assuming the larger square का side as a units. तो उसका area कितना हो जाएगा guys? A square. So I seek the value of a square in the question. मुझे a square का value आ गया, I've got my answer, right? So now guys, if you look at the horizontal side, okay, this complete distance, okay, I'll indicate this with a blue line next. Okay, this blue line will be nothing but a, right? ये तो पूरा a ही है. This entire length is a units, and this is the side of smaller square 3 centimeters, right? So this entire blue line is a plus 3, isn't it, guys? Right? Same way, if you look at the vertical distance, okay, the complete length of the larger square is a. Usme se you are removing these 3 units, right? So the remaining length is a minus 3, isn't it? Now, guys, I have a right angle triangle having sides a minus 3, a plus 3, and 30. Apply the Pythagoras theorem. You have the value of a square within seconds, right? A square is 440